going to explain about the sign conventions for reflection by spherical mirror. That means in case of measuring distance for object or image, we have to use a new sign convention. Okay, so this sign convention states that while dealing with the reflection of light by spherical mirrors, we follow a set of sign conventions, and these sign conventions are called new Cartesian sign conventions. These are just similar to like the Cartesian sign conventions, so this is considered as a new Cartesian sign conventions. So as you can see here, this is a suppose concave mirror. What is this? And this is a concave mirror, and this is the principal axis. In this case, we will consider the pole of the spherical mirror as the origin, and so if you consider this is the origin, so on the right side will be your positive and your left side will be negative. That means from this pole, if you measure any distance from P to B or B1 anything, then it will be negative, and in the upward direction that will be positive, in the downward direction will be negative. Okay, so suppose here AB is the object and the light come from the AB object in this direction, left to right. So this is the I have written the direction of incident light. And what is object? This AB is the object. This is a positive height. C for center of curvature, F for principal focus, and here A1 B1 is the image. Okay, so image is inverted. It will be a real image. So it is an inverted image. So image is in the downward direction. So its height will be negative. So you see here negative distance towards the left. Okay, so towards the left of the pole it will be negative, and towards the right of the pole will be what? Positive distance towards the pole of the mirror. So in this sign convention, the pole of the spherical mirror is taken as origin. So I already mentioned you, we will consider the pole of the mirror will be what? As a origin. So the principal axis of the spherical mirror is taken as x-axis of the coordinate system. So this is the principal axis, and this principal axis is considered as what? X-axis. The sign conventions are as follow. Number 1, the object is always kept on the left side of the mirror. So you have see here AB is object, so we have to put the object always in the left side. Okay, so in this convention the object is always kept in the left side of the mirror. Number 2, the distance parallel to the principal axis are measured from the pole of the spherical mirror. So any distance, maybe the object distance, maybe the image distance, maybe the distance of principal focus, all distance that are parallel to the principal axis will be measured from the pole of the spherical mirror. Okay. Number 3, all the distance measured to the right of the origin, that is along the positive x-axis, are taken as positive. So I already mentioned towards the right of the pole of the mirror will be what? Will be considered as a positive. And while measuring the distance towards the left of the origin, they are taken as negative. Okay, so from the pole, if you measure on the left, then it will be what? Negative. In the right, it will be positive. Number 4, the distance, that is the height measured perpendicular and above the principal axis, that is, okay, you see here the distance, that is the height measured perpendicular and above the principal axis, that is along x-axis, positive y-axis, are taken as positive. So while measuring the height of object that is perpendicular, and above the principal axis, this height will be what? Positive. Next, number 5, the distance, there is the height measured perpendicular and below the principal axis, that is along the negative y-axis, are taken as negative. So the distance that is measured below the principal axis and that is perpendicular that is in the negative y direction is taken as negative. Okay, so while measuring the height of a1 b1, height of the image, that will be always negative. Suppose the object height is suppose 5 centimeter, then it will be plus 5 centimeter, and if the image height is suppose 3 centimeter, then it will be minus 3 centimeter. Why the object is positive? Because in the upward direction. And why the height of image is negative? Because it is in the downward direction. Okay, and suppose the object distance, that is AB, from the pole is 10 centimeter, then from P point to B point this distance will be minus 10 centimeter. That is the distance of the object from the pole will be negative. And distance of the image, that is also in the left of the pole, so it will be also negative, that is suppose minus 7 centimeter, like this. Okay, so it is said that, again I repeat, while measuring the distance from pole in the left, then it will be negative. If you measuring the distance from pole to the right, then it will be positive. And if you are measuring the height of object in the upward direction, okay, that will be positive. And if you are measuring the height of the image in the downward direction, that will be negative. So these are the sign convention for reflection by spherical mirror. Okay, the next topic for us is the important points for measuring the distance on new Cartesian conventions. So let's see what are the important points. Number A, for concave mirror, when the image is real. So in case of concave mirror, we obtain what? We obtain real image, and sometimes the image may be also virtual. But let's see, in case of when the image is real, what is the condition? So you see here object, this is the object, and I have written plus h because why it is in the upward direction, that is in the positive y-axis direction, so its height is positive, that is plus h naught. And this is the pole, and this C for center of curvature, F for focus, principal focus. And as you know, in case of real image, the height of the image is in the image is inverted. Okay, that is in a downward direction, in the negative y-axis. So if you measure the height of the image, this will be what? Negative. Okay, and minus v, here you see what is v for? V for image distance from the pole. From the pole, if you measure the distance of the image, that will be negative v. Why negative v? Because image distance is negative as you are measuring from in the left of the pole. And here it is the object. If you are measuring the distance of the object from the pole, that is represented by minus u. Why? Because negative is because you are measuring from the pole in the left direction, and u for representation for object distance from the pole. Okay, u for object distance from the pole of the spherical mirror, and v for image distance from the pole. And here r is the radius of curvature, it is the distance of center of curvature from the pole, and it is negative. This is also because in the left side. And small f for what? Focal length, that is the distance of principal focus from the pole, and this is also negative because it is also on the left of the pole. So in this case, we have obtained that when the image is real, all the object, image, all these are what? In the left, and therefore these are all negative. Only the height of the object is positive because it's in the upward direction. Clear? So let's see, the object distance from the pole of the mirror is always negative. Why? Because it is convention that the object is always need to be kept in the left of the pole, and while measuring the distance from pole in the left direction, that will be always negative. Okay, so the object distance from the pole of the mirror will be negative, that is minus u, and the image distance from the pole of the mirror will be minus v, that is also negative because it is also real images are always formed in front of the mirror, and therefore distance will be minus v. The focal length and the radius of curvature are always negative because this focal length and the radius of curvature are always in the left of the pole of the mirror in case of concave mirror. Okay. Number B, for concave mirror when the image is virtual. As you know that when the object is kept between the principal focus and the pole, then we obtain a what partial image. So here object, you see this object is placed between F and P, and hence we will obtain a partial image. And where is the partial image is from? That is behind the mirror. Okay, and the nature of the partial image is that the partial images are also erect. Okay, so while measuring the distance of this object and image, we see here the object is minus u, because you are measuring this distance of the object from the pole in the left direction. From pole we are measuring the object distance in the left, so this minus u. And while measuring the distance of the image from the pole, it is in the positive direction, that is plus phi. Okay, so as you know that while measuring from pole in the positive x-axis direction, that will be always positive. If you are measuring in the left direction, it will be negative. So what is F principal focus? So you are also measuring it from the pole in the left direction, so this is also minus F. And C, center of curvature, so distance from pole to the center of curvature is what? Minus R, that is the negative is because in the left, and R for radius of curvature. Okay, therefore we obtain that the object, that is object distance of the object, that is u from the pole of the mirror, is always negative as it is in the left of the mirror. And the distance of the image, that is phi from the pole of the mirror, is positive because the partial images are formed behind the mirror in the right direction of the pole. Okay, and the focal length and the radius of curvature are always positive, because in case of concave mirror, your principal focus and center of curvature are always in the left of the pole, therefore they are always negative. Next, number C, for convex mirror. So as we know that in case of convex mirror, the image is always partial, and partial means that the image will be formed behind the mirror. So as you can see here, the object by convention, as you know, the object will always need to be kept on the left of the mirror. So object is on the left of the mirror, and image that is formed is in the behind the mirror. Why? Because the image is partial. Okay, so measuring the distance of the object from the pole, that is minus u, because you are measuring the distance of the object from pole in the left, so it is minus u object distance. And image is plus v, because you are measuring in the right direction, so plus v. Okay, so in case of convex mirror, you see here the principal focus and center of curvature are in the right of the pole. Okay, so if you measure the distance, the focal length from pole will be what? Positive, and the radius of curvature will also positive. Why? Because they are in the right of the pole. Okay, therefore the distance of object u from the pole of the mirror is always negative. Why? Because the object is always in the left of the pole, that is in front of the mirror, that's why it is negative. Number 2, the distance of the image from the pole of the mirror is always positive. As you know that in case of convex mirror, the image is always partial, so the partial images are always from behind the mirror, that is in the right of the, that is in the right direction, in the right of the pole. Therefore the distance of the image is always positive. Next, number C, the focal length and radius of curvature are always positive. As you see, the focal length and radius of curvature are also in the right of the pole, therefore they are also always positive. Okay, so these are the some important points for measuring distance on new Cartesian convention, okay, in both case of concave as well as convex mirror.